to lesson 7.3, where we are going to do what is called the unit circle. Now, this lesson is huge because the unit circle is something that you must memorize. So everything we do today has to be memorized. So we're actually going to start using those special triangles that we talked about last class. I want to review these really quickly. So 45, 45, 90, we said the first rule is that the small sides are the same, and then the second rule is to get between the small sides and the big side, we use root 2. Now, if we're getting to a bigger side, we times by root 2. If we're getting to a smaller side, we divide by root 2. And I'm going to start with just that right now. Let's just focus on that one. Now let's go to this unit circle, and I'm going to zoom in right here, because you'll notice that right here on the line that says 45 degrees, I'm going to make a right triangle, where this side is my radius, just like we learned last class period. Then the side-to-side part of this triangle is my x value, and the up and down part of my triangle, so there's my x, and then the up and down part of my triangle is my y, because we've known forever that x is always side to side and y is always up and down. Now, the angle we care about is this one right here, and it's 45 degrees. That's where this number in the box comes from, is the measurement of this angle right here. Now, the next thing that I want to do is, because this is a special right triangle, I can use some patterns on it, just like we did up here. But I need to know a side before I start it. So what we need to know first is this radius. Now, there's a reason we call this the unit circle. And it's because the radius of this circle is always 1 unit. That's where that name, the unit circle, comes from. The radius is 1 unit. So I know that that radius is 1. Now I also know these small sides are going to be the same, because it's a 45, 45, 90. And if I want to get from this bigger side to either one of the smaller sides, I'm going to use that root 2. Now I'm getting from something bigger to something smaller. So if I want to make it smaller, I'm going to divide by root 2. So 1 divided by root 2. And then I know that the other side is going to be the same, because on a 45, 45, 90, the two small sides are the same. So this is the triangle all filled out. Now I can use this information to fill out this point, because this point is just x, comma, y. Well, my x value is 1 over root 2. My y value is 1 over root 2. And then we have a point. Ta-da! Sweet. Now, there's one other big thing I want to mention with this point. There's this thing in math. Some really old mathematician dude came around a while ago and said, we don't like roots in the denominator. Kind of like if I were going to write this fraction, you would go, Mrs. Johnson, don't do that. We don't put decimals in the denominator of a fraction. It's gross. We just don't. Well, some mathematician forever ago said we shouldn't do that with roots either. So there's this process called rationalizing the denominator. And I'm not going to make you do this in class, but it's a very common ACT question, so I wanted to go over it once. Rationalizing the denominator. To rationalize a root denominator, you're going to multiply the denominator by itself. So I multiplied by itself, and I'm going to put the same on top and bottom to keep it balanced. So if I multiply across, I get 1 times root 2 on the top, and root 2 times root 2 on the bottom. So 1 times root 2 is root 2. Root 2 times root 2, I can combine those under one root. So that's going to give me root 4. And root 4 is just 2. So essentially what I'm getting at is 1 over root 2 is the same thing as root 2 over 2. Those are exactly the same number. This one just has its denominator rationalized, meaning we don't have a root down there anymore. So if you just Google the unit circle, they're probably going to use this number. And I don't want you to think, Mrs. Johnson, they have a different number, because they don't. Those are the same thing. And I will accept either on your skill check and test. Either that one or that one. They're the same. Okay, now that we've had that discussion, the only thing we need to do is we can actually use this point to fill in 3 more points. And this should be relieving, because you might be thinking, Mrs. Johnson, if I have to do this for every single one of these, it's going to take forever. Well, you don't. So what we're going to use is a process of reflection. So if I take this point here and I reflect it across the circle. And if I reflect that point across the circle, so take this point and reflect it across, it's going to line up with 135 degrees. Now what that means is that this 135 degrees is going to have the same point as the 45 degrees. So I reflect it across and I just copy it down. Now the only difference is in this quadrant, my x values are always positive and my y values are always positive. In this quadrant, the x values are always negative and the y values are always positive. So all I'm going to do is go to the x value, the first one, and add a negative sign. And there we go. Now, let's take that same point, and now let's reflect it down. So if I take that point and I reflect it down, now it's going to line up with this 225. So 225 is going to be the same point, except now in this quadrant, my x values are negative and my y values are negative. So I'm going to add negative signs to both of those. Now, one last thing. Let's reflect this point this way. So if I reflect it there, now it's going to line up with 315. So 315 is going to be the same point, except in this quadrant, my x values are always positive and my y values are always negative. So I'm going to add a negative in front of the second one, the y value. And there you go. You already have about 1/4 of the points written in, just from that one 45, 45, 90 special triangle. In the next video, we'll use the 30, 60, 90 special triangle to fill in some more of these points.